Welcome to the Waking Up Podcast. This is Sam Harris, just back from the TED conference, which is always fun. It can be easy to be a little cynical about the TED conference. It is a bastion of privilege, famously so, but it is a really beautiful thing. It strikes me as almost a possible future religion of reason. It's obviously shot through with really cool and compelling science, but there's a lot of art and dance and music, and it's just this explosion of creativity. And when everyone comes together, it's very inspiring. Anyway, Chris Anderson, the owner and impresario at TED, it turns out he's a fan of the podcast, and at least two people who spoke this time were there as a direct result of him having heard my conversation with them here. Stuart Russell gave a very interesting talk on AI, and Tristan Harris got invited a mere week before the conference, so he had to quickly prepare his TED Talk. That's not nerve-wracking at all. He did a wonderful job, by the way, and when that comes online, I will push that out on social media. And there were other people there who had either been on the podcast or will be coming soon. And there were a few people there who I discovered there and will be inviting on the podcast. So it's great to see that the conversations I'm having here are getting amplified out in the real world. And it is fantastic that when I meet fascinating people out in the world, I have a venue where I can invite them to have a public conversation. I really can't tell you how gratifying that is, and it's totally different from writing books. And one is a completely solitary and solo endeavor. The other directly connects me to people I would have no other reason to interact with, necessarily. And it produces relationships and collaborations, and then affects not only what I do, but it changes what they can do. Tristan now has a great TED Talk that will go out to millions of people. And given that what he was talking about was both interesting and important, and his message is incredibly positive, it's just very gratifying to see the knock-on effects of the conversations we're having here. And at some point I'll get Chris Anderson himself on the podcast, because what he has done with TED is just incredible, and there's a lot to talk to him about. And I recently heard from the philosopher Will MacAskill, who was on the podcast a while back. Will, as you might recall, started the effective altruism movement. He's a moral philosopher at Oxford, focuses on problems like existential risk. And he also is just very good at quantifying the effects of how he uses his time. And apparently our conversation was effective. It's surprising that the net results here are easily quantified, but Will tells me that as a result of his appearance here, one tech CEO took the Giving What We Can pledge, which is a pledge to give 10% of your income away, and is planning to give $750,000 each year, and has already donated $250,000 through Will's Effective Altruism Fund. $130,000 was donated directly to GiveWell's recommended charities. And then another 50 people made lifetime pledges totaling $14 million to these charities. So, as Will said in his email, seems like a pretty good use of a few hours of our time. I would say so. Also, I'm starting to plan my live events that will start, I think, no sooner than October. I think that's the month where the live podcast tour will kick off. I'll bring you more information about those dates the moment I get them. I think what I'm going to do is attempt to do 2 podcasts at each event. So really make a night of it. Have one guest speak for an hour and a half or so, and then have an intermission at some appropriate venue where you can all go to the bar, and then do another one. So bringing you 2 guests at each event, and probably won't announce those guests in advance. I think those will be a surprise, but they will be good people and we will have interesting conversations. And again, the first opportunity to get tickets for these events will go out to those of you who are supporting the podcast. So I have your email addresses either through Patreon or through my own website, depending on how you're supporting it. The only tricky part here is we need to pick a cutoff time where we will download the list of email addresses we have for all of you. So I think what will happen is I will just announce when tickets are available, and if you are on the list at that point, you will get the link. And if you start supporting the podcast at some point after that, well, then you will automatically be on the list for the next announcement. And I'll just have rolling announcements of dates as they become available. And what I'm picturing is 1 or 2 events a month, continuing for the next year or so, starting in the fall. I'm also planning a podcast tour of Australia, probably from March. So we're taking the show on the road, and I'm looking forward to it. And I've got some good people coming up very soon here. We've got Siddhartha Mukherjee, the physician and very fine New Yorker writer who wrote the Pulitzer Prize-winning The Emperor of All Maladies, big book on cancer, and his new book, The Gene, which we'll be talking about. Also got the historian Timothy Snyder, who wrote this short and very beautiful book on tyranny. The scientist Robert Sapolsky, who has a new book, which I'm very much looking forward to reading. And Sarah Hayter, who many of you have requested. Fareed Zakaria, Kevin Kelly. Kevin and I really disagree about AI, so that should be fun. Anyway, lots to talk about with these people. But today I have Gary Taubes. Gary is the author of 3 fairly recent books on nutrition: Good Calories, Bad Calories, Why We Get Fat, and most recently, The Case Against Sugar. He's a former staff writer for Discover and a correspondent for the scientific journal Science. His writing has appeared in the New York Times Magazine, The Atlantic, Esquire. He's been included in numerous Best of anthologies, including the Best of American Science Writing, 2010, received many awards, and has become fairly controversial for the very strong position he has taken on diet and human health, and the degree to which he has criticized the field of nutrition science. He has the knocks and bruises to show for having courted such controversy, but we had a very interesting conversation, and it's one that may actually influence how you eat and what you feed your kids. And now I bring you Gary Taubes. I am here with Gary Taubes. Gary, thanks for coming on the podcast.
Thank you, Sam. Pleasure to be here.
So let's start with your background as a journalist. I think many people are familiar with you, but you have a long background as a science journalist, and you've now focused of late on the science and pseudoscience of nutrition, and you've spent 3 books on this. You wrote Good Calories, Bad Calories, which was a very large and very well footnoted book. And then you wrote Why We Get Fat, and now The Case Against Sugar. And all of these are honing in on the same thesis, essentially, and making it more accessible to readers. These books were born of at least one very controversial article that I think was in the New York Times Magazine. How have you approached your writing career thus far, and what's caused you to focus on nutrition to this degree?
When I started my journalism career, I started, as you mentioned, as a science writer. My background was in physics, so I was naturally going to focus on physics. And my first 2 books, my first book, I lived at CERN, the big physics lab outside Geneva, and was embedded with a research collaboration of physicists who, over the course of the 10 months I was living with them, basically discovered non-existent elementary particles and then realized slowly their mistake. And then by the time I left to write the book, were willing to publicly acknowledge that they had screwed up. And then this led me to a kind of obsession and fascination with this question of how to do science right, which is excruciatingly difficult, and how easy it is to get the wrong answer. So I did a series of investigations, both for Discover magazine, and then my second book was on this scientific fiasco, cold fusion,
Mm-hmm.
which I always saw as I actually wrote it hoping it would be a case study that every young researcher would have to read before they engaged in a research career, because it was basically about how making an error of any magnitude could ruin your career in a functioning scientific environment.
Just remind me, what was the cold fusion scandal? Was it a conscious fraud on some level, or was it just a mistake?
I concluded for the most part that it was just a mistake, but it was a mistake that yeah, the researchers involved at the University of Utah clearly made up data,
Mm-hmm.
which in a it's technically misconduct, it's technically fraud, but the reason they made up the data is because their incorrect discovery was being stolen from them by a physicist down the road at Brigham Young University.
Stealing fiction. That's fantastic.
It's it's funny. There's still an option out on my cold fusion book by a now very successful Hollywood director who sees it as a wonderful comedic story about science. But if you think you've discovered something and you have premature data, and then somebody who should know is stealing it from you, then that's seems to be compelling evidence that it must be real. But now you don't have enough data to actually publish your own paper. So then what do you do? And what they did was made it up.
Mm.
So technically it was fraud, but they were such idiots on some level that it's even hard to say whether they knew they were doing something wrong when they did that.
Mm.
Crazy story. So anyway, that led me. I had a lot of friends in the physics community after doing these two books, a lot of physicists who saw me as a kind of investigative journalist, that they could point at a subject that smelled suspicious to them and kind of pull the trigger, and I would go investigate it. And so several of these physicists suggested in the early 90s that I get into looking at the science and public health, because they thought it was terrible, and indeed it was. Everything I had learned from these brilliant experimental scientists in the 80s that was required, not everything, but most things that they considered required to do science right and minimize the possibility that you're fooling yourself, is considered kind of luxuries in the field of public health. It's just too hard to do it. It's too expensive to do it. Your systems, human beings living in the real world, are so messy. So rather than acknowledge that they can't establish reliable knowledge, what the community kind of did en masse, unconscious decision to just lower the standards that they would use to establish causality,
Mm.
to make statements about what is or is not a healthy diet, which is the area I ended up focusing on. So by the late 90s, I was writing these investigations for Science, first on this issue of whether salt caused high blood pressure, which seems to be common knowledge and the basis of dietary advice since the 1980s. And you look at the evidence, it's just not there. Unless God told you personally that salt, I know as soon as I say that, I'm stepping into dangerous ground here. But unless God tells you personally that salt caused high blood pressure, you'd never conclude that from the evidence, from the randomized controlled trials.
This is really just one of the great scandals of science at this point, that there's still so much confusion about what constitutes a healthy diet. I mean, so like, I just imagine if I went to see a cardiologist today and I told him that I eat, every day for breakfast a bowl of oatmeal and drank a glass of orange juice, say. Some number of cardiologists, a significant percentage, would say that's great.
Bravo, right.
Some would probably say I'm living on the edge, and I think you would probably say I'm living on the edge. And conversely, if I said I ate a plate of eggs and bacon every morning, many cardiologists, certainly most, would say that I'm attempting a slow suicide, whereas some would say that is optimal, right? So it's just like, how is it that we're in this situation? I mean, we're getting ready to colonize Mars, and we cannot agree about what would be healthy food to take for the trip. It's a crazy situation.
Well, and it's worse than that, because this situation exists in the midst of an unprecedented epidemics of obesity and diabetes. Right, so over a third of the population is considered clinically obese, 2/3 is overweight, something like almost 10%, almost 1 in 10 Americans are diabetic, a disease that was vanishingly rare just 120 years ago. So you would think, right, that and beset by these epidemics, there would be like we wouldn't be able to cross the street in our neighborhoods without tripping over some scientific committee trying to figure out what we did wrong, what we don't understand about the nature of a healthy diet. And instead, there's this sort of placid acceptance that, well, people just eat poorly and we tell them how to eat, and we've been telling them how to eat for 50 years and nobody listens, and everyone goes to McDonald's and Taco Bell, and that's the cause of the epidemic, and that's what makes us fat. And yeah, it's a crazy situation. I mean, I've been stuck in the middle of it because I am one of these people who think you'd be healthier if you ate the bacon and eggs. I often describe myself as the kind of person who believes that bacon and butter are health foods, and at least if I'm killing myself, I'll die relatively happy. Knock on wood. Jesus, I'm talking to you. I've evoked God and the fact that I'm superstitious in the first 5 minutes.
That's all right. If you sneeze, I'll probably say God bless you. It's deeply wired in the brain.
Okay. So yeah, I've tried to document this. My first book, Good Calories, Bad Calories. The two investigations I did for science, first on salt and blood pressure, and then on this belief that a low-fat diet is a healthy diet, those led me to that infamous New York Times Magazine cover story, What If It's All Been a Big Fat Lie? And by that point, I was pretty confident that the science of nutrition was, that it's as you put it, it's a pseudoscience of nutrition. It's not a functioning science, as the scientists that I knew would call it. And so, I spent the next 5 years of my life investigating and trying to figure out what other mistakes had been made, where the mistakes might have been made, what you have to do to fix it. But then that puts me in the position of being a journalist saying all the authorities are wrong. And while the doctors, you could go to the different cardiologists in your neighborhood might disagree on what's a healthy diet. The nutrition community, the influential nutritionists, for the most part, all agree. And it's reflected in the public health guidelines.
Let's talk about your basic thesis here. So what is your criticism of the current state of conventional wisdom, and what do you actually think is the ground truth of what we now have good reason to believe is healthy to eat?
Okay, so there are three more or less fundamental pillars of all nutrition science regarding a healthy diet, regarding what we should eat on a day-to-day level to be healthy. So the most fundamental is this idea that we get fat because we eat too many calories. The technical terminology for it, because people need a technical terminology when they have a particularly stupid idea, is the energy balance hypothesis or theory of obesity. And you'll see articles. I just downloaded one today that was a working group report from the International Agency for Research on Cancer. And the idea is that obesity is an energy balance disorder. You take in more calories than you expend, you get fatter. That's sort of the basis of everything, because the nutrition community knows that once you get fatter, as you get more obese, you increase your risk of diabetes and heart disease and cancer and gout and all these other diseases. So if you want to prevent that from happening, if you want to minimize your risk, the first thing to do is you're supposed to balance your calories into your calories out. And it turns out when you look at the literature, you go back, that it's an idea that came out of nutrition science from the 1870s to the 1920s. So modern nutrition science actually dates to the late 1860s, when German researchers created devices called calorimeters, room-sized devices that can measure the energy expenditure of humans or animal subjects living in these rooms. So you could measure the energy content of food by burning them and burning the food in what's called a bomb calorimeter. Now you can measure the energy expenditure of humans and dogs, and the researchers start doing this around the same time that other researchers are working out the laws of thermodynamics and concluding that the laws of thermodynamics hold for animate as well as inanimate objects. And by the early 1900s, you have a theory of obesity that it's caused by consuming more energy than you expend, because that's all the research community could measure. So the idea is that the way foods influence our weight is through their caloric content only. And there's this idea, that phrase you've heard, a calorie is a calorie is a calorie.
Mm-hmm.
Because a calorie of protein and a calorie of carbohydrates and a calorie of fat all brings the same amount of energy into your body. But the problem is that belief system is technology dependent. If all you can measure is the energy content of food, then you come up with a hypothesis that the energy content of food determines your weight. Beginning around 1920, the science of endocrinology, hormones and hormone-related diseases, begins to grow and mature. It's pioneered in Germany and Austria. And the Germans and Austrians come to this conclusion that clearly obesity's got to be a hormonal regulatory defect. They look at, like, men and women fatten differently. Men fatten above the waist, women fatten below the waist. So sex hormones have to be involved, right? When boys and girls go through puberty, boys lose weight and lose fat and gain muscle. Girls gain fat and gain it in very specific places. They've got to be hormonal control of fat accumulation. But the American scientists who began to dominate the field, or first of all, they just didn't understand. They weren't scientists, they were doctors. They didn't understand endocrinology. They were wedded to this idea that fat people just eat too much. They saw a hormonal explanation for obesity as an excuse for fat people to remain sort of gluttons and sloths. And they talked about it. You can see it in the literature and articles in the Journal of the American Medical Association in 1925, when whoever wrote, I can guarantee whoever wrote that article didn't have a clue what endocrinology was, is arguing that obesity is a hormonal disorder. And then again, the Germans and Austrians are arguing clearly it's got to be. Just you cannot explain anything meaningful about obesity by this energy conception.
Let me just ask a few questions here to kind of bound how far-reaching your claims are here, because you're not disputing thermodynamics.
No,
I assume so.
I got a physics degree. I'm not allowed to.
Right, or you would be far more famous than you are if you were disputing it credibly. So I imagine you would admit that on some level you gain weight because of a surplus of calories. So for instance, if I were going to eat 15,000 extra calories a day, it wouldn't matter if those were extra carb, fat, or protein calories. If I was at that surplus day in, day out, I'm going to just keep gaining weight, right?
Yeah, although actually it might matter. You might, but again, it depends how you define excess. Let's use a metaphor, an analogy to help understand. Let's say instead of thinking in terms of excess weight, we're talking about excess money or wealth instead of obesity. Okay, so now clearly you can't get rich without making more money than you spend, right? But you would never say that you got rich because you made more money than you spent.
There are certainly degrees of that disparity, and where you put the line is a judgment call, but it's not just a matter of
where you put the causality. Because again, to get rich, you have to make more money than you spend. That's a given.
Right.
The conservation of money, just like, unless you're a counterfeiter, just like there's conservation of energy. So to get fat, it means you're taking in more energy than you're expending. But you might get fat because, for instance, I can give you a drug that makes your fat tissue accumulate fat.
What you're saying clearly is that there's more to the story, so that
I'm claiming that as soon as you went to causality, as soon as you say, and again, we'd never do it in any other field. Think about climate. Let's use climate change as an example. Clearly, if the atmosphere is heating up, it's taking in more energy than it expends, right? Otherwise, it wouldn't heat up.
Right.
But the question is, why is it taking in more energy than it expends? One possibility is that the sun is heating up. So we're getting more energy from the atmosphere, but we're pretty confident that's not happening.
Right.
Another possibility might be that we actually have a heat trapping phenomenon going on in the atmosphere, in theory, which I believe for the most part. And so the fact that the atmosphere is taking in more energy than it expends and it lets out is irrelevant. What we want to know is, why is energy being trapped in certain areas of the atmosphere? Why do certain frequencies of light get trapped and not others? Why do certain molecules trap heat in the atmosphere and not others? And what's the source of those molecules? You could think of it as a heat trapping problem.
Right.
And then you don't think about how much is going in or out. You don't care about that, even though clearly more is coming in. You know, you could think, if you're getting richer, your bank account is accumulating money.
Yes, but if I suddenly, again, to take the wealth case, if I suddenly told you that I'm now going to spend 10 times more than I earn, and
Right.
I'm committed to doing that, you can predict that if I live long enough under this regime, I'm going to go broke. And so you're not disputing that basic picture. There's nothing magical here about the hormones. I think you're saying that the difference between our macronutrients and how they interact with the endocrine system brings many other variables into play, including things like a person's level of appetite, a person's level of involuntary energy expenditure.
Well,
I mean, there are other things happening, right?
But you're still thinking in terms of the fat mass being fundamentally controlled by how much people eat and exercise, by intake and expenditure. And what I'm saying, so think of, let's use children's growth as an example. Okay, now we could starve a child, can't do this as an experiment, and stunt its growth. Okay, clearly happens in famines all the time, but we would never say that the child grows because he eats a lot of food. Having a lot of food available certainly allows growth to happen, but the growth is pretty much food independent, or not protein independent, so different macronutrients have different effects. But if we were talking about growth, so again, we could look at the boys and girls going through puberty as an example. They're both getting bigger, right? They're both getting heavier, so we know they're taking in more calories than they expend, because that's what the laws of thermodynamics tell us. But the boys lose fat and gain muscle, and the girls gain fat. So now the fact that they're taking in more calories than they expend is irrelevant to understanding why the boys lost fat and gained muscle, and why the girls gained fat, and where the girls gained fat, because it doesn't happen everywhere.
Right. So there are other examples come to mind. So for instance, you wouldn't say of the growth of cancer tumors that that's best explained by a surplus of calories.
Exactly.
Okay, so there's more to the story. So it's
not just that there's more to the story, but if you think of, like, you could think of cancer as a caloric energy balance problem, because clearly the tumors are growing. And if you needed to push the analogy, and I've got slides to this effect that I use on talk, you can find examples of like benign tumorous masses that weigh 50 pounds, 100 pounds. And, so still you wouldn't think of it as an energy balance disorder, despite the fact that whoever had that 50-pound or 100-pound benign mass had to take in enough energy to create the tumor. And if you thought about it as an energy balance disorder, you would not understand the etiology of that mass.
Right. So what is the etiology, in your view, of the obesity epidemic?
So what happens in the 60s, and remember this is only one of the fundamental pillars, so we still have two more to get to.
Yeah.
Endocrinology begins to be understood in the 1920s on some profound level. Insulin's discovered, growth hormone is discovered, other hormones are discovered. It's a German-Austrian occupation. The Austrians are arguing that obesity is clearly a hormonal regulatory defect, and that discussing it in terms of energy balance is meaningless. Because again, it's like discussing the puberty issue, which was one of the examples they used in the literature. The war comes around, the German-Austrian school evaporates, and the lingua franca of medicine switches from German to English. And post-war, the science of obesity is in effect recreated by young nutritionists and doctors at the Harvard School of Public Health and elsewhere have no clinical experience with obesity and just embrace this energy balance ideas. Clearly fat people just eat too much. We know this because I know a fat person and he eats a lot. That's about the depth of the thinking. And by the 1960s, obesity is considered an eating disorder, and it's studied primarily by psychologists and psychiatrists. The 1960, couple of researchers in New York create something called the radioimmunoassay that allows you to measure hormones in the bloodstream for the first time accurately. One of them later wins the Nobel Prize for the work. In the 1960s, see an explosion in the field of endocrinology. And by 1965, it's clear that fat accumulation in fat cells is primarily regulated by the hormone insulin. And this is conventional wisdom. You could look at biochemistry books and endocrinology textbooks today, and they'll tell you the same thing.
So remind people what is the role of insulin in regulating fat storage?
So we think of insulin as the hormone that's defective in diabetes. In type 1 diabetes, which is the acute form that usually hits in childhood, your pancreas doesn't secrete enough insulin or doesn't secrete any. And in type 2 diabetes, which is the very common form, 95% of all cases, it associates with excess weight and age. Patients actually begin as what it's called insulin resistant. So their pancreas secretes insulin in response to their diet, and the insulin controls their blood sugar, but it doesn't do a good job of it. So they have to secrete more insulin to keep their blood sugar control, and they have elevated levels of insulin in their blood throughout the day. So by 1965, it's clear that insulin not only tells your lean tissue, your muscle cells, and your organs to take up glucose, carbohydrates that constitute your blood sugar to keep the blood sugar in control. They also tell your fat tissue to take up fat and hold on to fat. So by 1965, insulin is being described, including by the couple that created the radioimmunoassay, and Rosalind Yalow, the physicist in the pair, later won the Nobel Prize. Her partner, Solomon Bersin, passed away. Yalow and Bersin are describing insulin as the most lipogenic hormone, meaning it's fat, forms fat, stimulates fat formation, and the more insulin, the more fat you're going to accumulate. And the problem is, to the field in general, a few things happen. First of all, working physicians read the medical literature, and they say to themselves, look, if insulin stimulates fat formation, and we secrete insulin in response to the carbohydrate content of the diet, which we do, what happens if you just don't eat carbohydrates? And in fact, they find out that you happen to lose a lot of weight. And this is the genesis of the Atkins diet. Atkins was a cardiologist in New York who read that literature and said, gee, it seems to me if I remove the carbs and replace it with fat, so I eat a high-fat diet, bacon double cheeseburgers without the bun, I should lose weight because I'm going to lower insulin. If I lower insulin, I'm going to mobilize fat from my fat tissue. And they write these very best-selling diet books. And the medical community responds. The cardiology community responds. They're beginning to believe the second pillar of the nutritional wisdom, which is that dietary fat causes heart disease. If dietary fat causes heart disease, Atkins is going to kill more people than Hitler did. That's an extreme example, but so this scares them. So not only do they have to sort of beat down Atkins, which they do with a kind of vicious critique in the American Heart Association, I guess it was, forget which journal it was, JAMA or the American Heart Association journal, but they say that these diets are quack diets, they're fad diets, they will kill people.
Yeah, are we talking about the 90s now? When's this happening?
This is way back in the 60s.
But Atkins became very prominent with his books much later than that, right?
No, 19. He started to become prominent in New York in the magazine world in the late 1960s. 1973 was when he published his book, which is right around the time that this belief that dietary fat caused heart disease was gelling.
Well, that's interesting because my awareness of Atkins came much later. There seemed like there was a resurgence of interest in his diet
That was
some decades after that.
my piece in 2002 in the New York Times Magazine, which was a kind of seen as an apologia for Atkins, because I basically said he might have gotten it right.
So that piece in the New York Times Magazine kind of resurrected Atkins, or was he humming along this whole time?
He was still around. He was still publishing books. People and were still buying the books. But yeah, my piece more or less resurrected it, then prompted Michael Pollan to then write his books in response to the lunacy of anyone suggesting that all of America should be on something like an Atkins diet. Yeah, that was interesting. The problem happened though. The disconnect between what the science, the evidence said, and the way the field embraced that evidence happened in the 1960s and 1970s.
Okay, so this is just to keep everyone clear here that you've told us about the first and now second pillar. Remind us what they are, and let's get to the third pillar before I distract you again.
The first pillar is this idea that obesity is an energy balance disorder, is caused by taking in more calories than expends, rather than being a hormonal regulatory disorder where the dysregulation is caused by what foods you eat rather than how much you eat. So basically, I can feed you foods, and the idea is they're easily digestible carbohydrates, refined grains, and sugars, and they will work to elevate your insulin levels by two different mechanisms. And once your insulin levels are elevated, you will store fat. And if you're losing calories into your fat cell, because now some of what you're eating is being trapped as fat rather than used for energy, that in turn will make you hungrier and you'll eat more. You may even exercise less. But the primary effect of these foods is to make your fat tissue expand and accumulate calories as fat. Some foods are literally fattening independent of their caloric content, and other foods are literally not fattening independent of caloric content.
Okay, so that's your retort to the first pillar.
Yeah. Okay. And I can document, and I have documented again, where this hormonal regulatory disorder hypothesis died, literally 1941, and how the energy balance hypothesis is what the Europeans call the energy conception, took over in the US and dominated the field. And then in the 1970s, what's interesting about fields of science create paradigms, and paradigms shift when the fields are small and maybe a half dozen individuals can determine what's good science and what's not, sort of what has to be known, what's inconsistent, what experiments have to be done. For instance, in the revolution in molecular biology, it happens in the 1950s. And it's, Francis Crick and James Watson and half a dozen other people who made that revolution happen. And if you remove Francis Crick, you get no understanding of DNA in effect. And the same thing, theoretical physics, you could remove Julian Schwinger, and we don't have a standard model as we have today. In obesity, they had the same half dozen people. These guys just didn't know how to do science. They just weren't very smart. It's like, just like you have bad plumbers, we have bad scientists out there. And these guys dominated the field in the 1970s. And they didn't like the idea that a low carbohydrate, high fat diet was a preventive way to prevent or treat obesity, because they thought high fat would cause heart disease, and they thought fat people get fat because they eat too much.
Right. So high fat causes heart disease is the second pillar.
Yeah, it's the second pillar. So what they did is they just removed, and again, you could see this in the textbooks and the conference proceedings. They said, because we don't like the implications of the endocrinology, we are going to decide that endocrinology has no influence on obesity. We're just going to kind of remove it from the literature, to the point that 2 months ago, the New England Journal of Medicine publishes an article on the pathophysiology of obesity, pathophysiology and mechanisms of obesity, which is a disorder of excess fat accumulation. And there is zero discussion in the article of the hormones and enzymes that actually regulate fat accumulation. It's not considered relevant.
So I want to get to how you explain that, but just I don't want to leave the structure of your thesis hanging here. So what's the third pillar? And
So the
then we'll
third
get to that.
pillar is this idea that we should all eat mostly plant diets. So the second is, again, dietary fat causes heart disease, and then specifically saturated fat. And saturated fat is associated with the significant part of the saturated fat in our diet comes from animal products. Therefore, animal products cause heart disease. And out of this, we get this idea that we should all eat mostly plant diets, that populations or individuals that eat mostly plants or all plant-based diets are healthier than people aren't. And that in turn is based on this field of observational epidemiology.
The Mediterranean diet and all the rest. So well, let's just take the second pillar for a second. How do we know that saturated fat in the diet isn't a problem generally, and in particular isn't the primary source of cardiovascular disease?
Well, and on one level, you can't know it for sure. So we have to leave that possibility out anyway. You can't, all we could say is it likely to be a cause of heart disease or not? So, and here's where the epidemiology comes into this as well. Back in the 1960s, researchers in the US primarily were interested in why there's such high levels of heart disease in the US and certain European countries and not others. So what they basically did is said, let's look at these populations and see what they eat. And what they found was that populations that had high levels of heart disease ate a lot of saturated fat. There was a famous study called the 7-country study done by Ansel Keys at the University of Michigan. And so the populations that ate high levels of saturated fat, like the US and the UK, had high levels of heart disease, and populations that ate high levels of unsaturated fats did not. So Greece, hence the Mediterranean diet and their olive oil. And this is a kind of observational study that the question then becomes, if you see that people in the US eat a lot of saturated fat and have heart disease compared to some other country, does that mean they have heart disease because they eat a lot of saturated fat? So this is a question that, you've got an association between saturated fat consumption and heart disease, but that association logically, it holds no causal information. My mother used to say, what does that have to do with the price of tea in China? Which is sort of just because the price of tea in China is going up and heart disease is going up. We don't think there's an association there. We don't think it's causal. Why would we think the saturated fat thing's causal? So the only way to know if the saturated fat association is causal is to do randomized controlled trials, to basically intervene, change people's diets, and see if you tell them to eat more saturated fat or less saturated fat, well, they have more or less heart disease compared to whatever they replace that diet with. And as it turned out, trial after trial tried to test the saturated fat hypothesis, and for the most part failed to confirm it.
Just in defense of epidemiology, you could also find a population that is eating just as much saturated fat, or perhaps even more, but isn't eating, in this case, sugar,
Right.
and see that the correlation breaks down. Has that in fact been found as well?
Well, and again, that's the kind of issues you have with the level of science. Remember, I was told to go into this field, public health, because my physicist friends thought the science was terrible. So this famous 7-countries study that began to really shift Americans towards eating a Mediterranean diet and eating olive oil and polyunsaturated fats instead of saturated fats, looked at 7 countries around the world. So the US and the UK and Greece and Italy and I don't know, a couple of Scandinavian countries and Japan. I may have gotten that wrong, but that's the gist of it. The interesting thing is there are 2 countries right in the middle of Europe that eat very high saturated fat diets and have among the highest lifespans in the world, France and Switzerland. So you could just ask the question, instead of picking, for instance, Greece and Italy, had they picked France and Switzerland? So I lived in Geneva for a year. The 2 national dishes are both cheese dishes, fondue or something horrible called raclette that you got at every cocktail party you went to. clearly these people eat very, very high saturated fat. So depending on what countries you pick, you can get very different answers. As it turned out, Ansel Keys, the investigator who ran that study, didn't pick France and Switzerland. He picked Greece and Italy. This is the problem with those kind of observational studies. There's a host of problems with those kind of observational studies. I had another cover story in the New York Times Magazine in 2007 making that point, where these studies are basically uninterpretable. So what you get instead are researchers with preconceptions interpreting the answers to fit their preconceptions.
In those two cases, you've picked out societies where I wouldn't expect the sugar consumption to be especially low, certainly not the refined carbohydrate consumption.
Actually, in France,
I mean, aren't they
I
just eating
can't.
baguette and chocolate as rapaciously as any people who've ever been born?
Well, French sugar consumption is about 100 years behind ours. So they were
Is it really?
always
Yeah.
notoriously, not notoriously, but the sugar consumption in France was always about 30 to 50% of what ours was. Switzerland, I can't say, but I would assume it's the same. Or close.
Right.
In fact, the whole Mediterranean that people talk about, the French paradox, is actually a Mediterranean paradox, where all these countries, Spain, Italy, Greece, all had relatively high fat diets. Then, as you get into France and Switzerland, you go further north, the fat becomes more saturated and less olive oil based, but they all had relatively low heart disease rates. And when you actually dig into this literature, and I was the first journalist to really do this, I remember speaking to one British epidemiologist who had come originally from Australia, and he talked to me, he said, Australia had this huge Greek population that emigrated after World War II when Greece was decimated. He said they moved to Australia. They live on lamb chops and Foster's beer, and their heart disease risk goes down. And so, how do you explain that? And the question is, who knows? You've got to do randomized control trials. You cannot establish causality. The only times you can establish causality and with epidemiology is when you have a phenomenon like cigarette smoking and lung cancer. So you have exceedingly rare disease in non-smokers, and you could compare non-smokers to smokers, and you see a 20-fold increased risk of lung cancer in smokers versus non-smokers. And then the reason we believe it's causal is because you can't think of how to explain it.
Mm.
You can't think of an alternative hypothesis. Not that the cigarette industry didn't try, but you can't think of a viable alternative hypothesis other than cigarettes cause lung cancer. And of course, it makes eminent sense that clearly, if you're drawing smoke into your lungs, you could imagine that that would cause lung cancer. So it makes biological sense.
Mm.
But these other effects that we've based public health policy on are relatively tiny. They're not 20-fold increased risks. They're not 3 or 4-fold increased risks. They tend to be 20% increased risk or 50% increased risk.
Right.
And that's simply, you can imagine all too many things that could explain it.
It seems to me you do make this argument, at least in the background in your books, where you emphasize the correlation between I think what are called the diseases of Western civilization,
Right.
cardiovascular and peripheral vascular and things like gout. And there's a long list of
Yeah.
things that seem to come with when a traditional culture suddenly gains access to, in your case, the smoking gun is refined carbohydrates and especially sugar.
Sugar.
So it seems that you are talking about changes in populations where you show up among the Inuit, you see that they're eating nothing but whale blubber, or a lot of whale blubber, and they have no access to any refined carbohydrates, and they don't exhibit these pathologies until you start giving them bags of Doritos and soda, and then they have all the pathologies that we notice in Western societies. Isn't that part of your story that you're
Yeah,
telling?
absolutely. So you still, science is about, it's funny, I was a science journalist for, I don't know, 20 years before I got around to reading Claude Bernard's Introduction to the Study of Experimental Medicine, which he wrote in 1865. And Bernard said, science is about explaining what we observe. Ultimately, science is about explaining what we observe. And it's weird. I had never thought about that, but you've got observations, whether in the laboratory or in your particle accelerators or in nature. And everything we're trying to do is explain what the cause of those observations are. Is it some new fundamental particle? Is it, some carcinogen in the water supply? Is it, who knows? So the observation that led to this dietary fat hypothesis is that we had a lot of heart disease in the US. And then what I learned doing my research and what I sort of brought back from obscurity is that while US researchers were focusing on that, there was a sort of school of British research. The British had an advantage. They had missionary and colonial hospitals scattered all over the world. So researchers would be trained in the UK or in Europe, and then they would go work in Botswana land or some South Pacific island or Australia treating Aborigines. And wherever they were, they would document, report this, in effect, epidemic of obesity, diabetes, these Western diseases, hypertension, heart disease, cancer. They would all increase in prevalence and in some cases explode in prevalence as these populations all around the world became westernized. And then the question is, what is it about the Western diet that leads to this explosion of diseases? And this is conventional wisdom. And Michael Pollan, with whom I disagree on sort of two of the three of his his mantra, eat food, mostly plants, not too much. Yeah, Michael basically builds his argument from the same data, that same observation. And that's what you have. If you try to explain that, then you're asking the question, what is it that Western diets bring to these populations?
So you agree with him that we should eat food, but
I agree with
you're
him
not so sure about the plant part or the not too much part.
Yeah, the plants I'm not too sure about, and the not too much I think is meaningless. It's based on the assumption that you get fat if you eat too much, but then you can't define what too much is.
Except just to go back to thermodynamics for a second, you would agree that whatever macronutrient or food you thought was blameless, let's say, a steak, if I eat 15,000 calories of steak, as impossible as that may be in practice, I'm going to get fat unless I burn 15,001 calories.
Well, and so the question is, yeah, and again, we're going to get back, because this is the area that's so fascinating. Let's look at it a different way. Just again, I'm saying you could eat, which isn't going to be difficult, you could eat, say, 2,000 calories of steak a day plus 1,000 calories of green vegetables, so 3,000 calories total. Might be sound a little excessive, or you could eat 3,000 calories, of which, say, 1,000 is steak, 500 is mashed potatoes, 500 is orange juice, and 1,000 green vegetables. So they both are 3,000 calorie diets. One will make you fat, one won't. Okay.
That's a good ground truth to anchor this to.
So it's not, and it is true if you could force yourself. Actually, back in the 60s, there was a study done. I'm full of this useless knowledge. Ethan Sims at, I think it was, I always forget if Vermont or New Hampshire, did a study where he tried to overfeed convicts to force them to gain 20% of his weight. So first they tried with basically an Atkins-like diet, and they couldn't get the convicts to eat it. So your hypothetical, if I ate 15,000 calories of steak, in this situation, they couldn't get the convicts to eat 15,000 or even 8,000 or 7,000. They talked about, I interviewed all the various investigators who were still alive, and they talked about seeing these convicts sitting there with a plate of pork chops in front of them, just refusing to eat them.
That goes to one of the kind of confounding variables here, because what you eat for hormonal reasons, but probably also just for other reasons that we can't totally explain, changes your consumption behavior. Because, I mean, there's certain things no matter how much you like them, you're never going to binge on those foodstuffs, and steak is one of them.
Well, but then the question is, can you disassociate the effect on fat mass from the effect on appetite? So if your fat won't take up the calories and store it. So again, what happens when you start eating, even before you start eating, you start secreting insulin. It's called the cephalic phase insulin response. Cephalic means above the head. So you think about eating, or you watch a commercial, you start secreting insulin, because insulin is kind of an engineering problem. In order for insulin to control your blood sugar so it doesn't get too high, it's got to be in your bloodstream before you eat. And you could do this as an self-experiment. You could actually, I mean, just walk down to your kitchen, think about, pick a time when you don't think you're hungry, although you can't, just walk down to your kitchen and think about some sweet food you like, and suddenly you'll find this urge that you're getting hungrier. And that's most likely the cephalic phase insulin release. And then that starts basically telling your lean tissue to take up blood sugar, and your fat tissue to store calories as fat. And you can think of it as emptying your circulation of nutrients, which actually works to make you hungrier. So the French have a phrase that the appetite begins with the meal. And again, you can think of that all the times you sit down to eat, or if you have children, you can actually watch it happen. Your kids will say they're not hungry. And even it's the function of an appetizer in a meal is to literally give you food, and by doing so, make you hungry.
Right.
And again, these are the things, a lot of the best work on this was actually done by a brilliant French physiologist named Jacques Lamagnan, who happened to be blind. He had gotten encephalitis as a youth and had gone blind, so he started his research. He was fascinated by smell-based, odor-based phenomena, and then he moved into studying hunger and appetite. So the point is, we have a tendency, and the research community has a tendency to think that there's some concept called palatability or hyperpalatability or food reward that could be disassociated from the actual physiological effects of the food in the body.
Right.
And, I've been stuck in this position. So as I'm trying to, egomaniacally correct these fundamental pillars, beginning with this energy balance misconception, it means you can't just sort of you're tearing down the foundation of a house of cards. You can't, the rest of the foundation comes down with it. The rest of the house comes down with it. And then you kind of have to rebuild the science from there. It's one of the reasons why I'll never succeed at this, because the world is full of scientists whose very existence is based on studying phenomena that I would say are misconceived because of this belief that for instance, anyone who's studying obesity, who's studying hunger, has to be doing it in terms of the physiological phenomena that might stimulate hunger. And these are phenomena that occur below the neck. And again, there are a lot of fields of science in which this research was being done. And that's how one of the areas that led me to my conclusions is sort of field after field after field, you would find the researchers coming to the same conclusions. Again, that obesity is a hormonal regulatory defect. Like if you're studying fat accumulation in animals, you're not really thinking about how much they eat and exercise. You're thinking about how do their hormonal status affect fat accumulation. Even if livestock scientists think in terms of, hormones, and they know that animals, if they can make animals fatter, they will eat more. But they think in terms of what's regulating their fat tissue, not in terms of whether, they could make, and you can clearly make animals fatter by keeping them sedentary and force feeding them. But that's just pushing to the extreme natural phenomena. We're trying to understand natural phenomena.
Take me back to the New York Times Magazine article when you first exposed your interest, I think, in this topic. How controversial has this been? How controversial was that, and how controversial is your work currently? Because when I announced you're coming on the podcast, I started to receive some of your hate mail, and I'm obviously quite familiar with hate mail, and I certainly doubt you get more than my last guest, Charles Murray. So
I hope not.
I'm no stranger to controversy on the podcast, but people hit me with a few of your critics. There was this, I think he's a neurobiologist, Stéphane Guyenet, who wrote a review of your book on his website. And then I saw your response to that, which seemed good to me. And then there was another skirmish you had with an NIH researcher Kevin Hall, who did a
Yeah.
metabolic ward study, which I think you funded.
Yeah, my not-for-profit funded.
Right. Tell me the level of controversy, and then I want to hear your experience, but then I want you to prop up what you think are the best criticisms of the state of your knowledge thus far, and what questions remain to be answered.
Well, so let's talk about the bigger issue, which is, and I want to do this because it's very relevant to what you do. A journalist comes along and basically makes this claim. So we start with the New York Times Magazine article, which was, again, on some level, it was seen as an apologia to Atkins. I had Atkins in the original version buried buried deep in the article, and then the editors at the time, who were Adam Moss and Hugo Lindgren, terrific editors, recognized the great controversy when they saw it, and they said, yeah, put Atkins in the lead. And I wrote this lead about if the American Medical Association community had a find yourself standing naked nightmare in Times Square, it would be finding out that dietary fat doesn't cause heart disease, and maybe Robert Atkins was right, or both simultaneously. I forget the exact wording, and I read it to my wife, and I said, they won't run this in a million years. And I sent it in to them, and of course, it didn't change a word. And the cover's image of that article was meant to be as shocking as possible. And I recently saw the editor, Hugo Lindgren, about 3 months ago in New York, and Hugo told me that it was a ribeye steak with a big pat of butter on it. And they said they made sure they got a photo that made the ribeye look as greasy and as unappetizing as humanly possible. And then the headline is, "What if fat doesn't make you fat?" So the world was full of both journalists and public health authorities who had been arguing that dietary fat causes heart disease, that we should all eat low-fat diets. If I was right about what I was saying in that article, they were wrong. And nobody wants to accept that they were wrong. And some of those people included, the health and nutrition reporter for the Washington Post, or the entire Center for Science and the Public Interest. So these people, and even some of my friends who had written books arguing that, basically taking the conventional wisdom in obesity and weight loss diets. And so these people had to establish that indeed they weren't wrong and that I was wrong. And they did. In various, major articles, and it was an interesting experience to be. I knew this piece was going to be controversial. I had no idea of how it was going to play out, and it still doesn't cease to surprise me.
It must be one of the most read articles they've ever had in the magazine, right?
I would think so, and probably one of the most, I think, clearly in the top 5 most controversial. Maybe the most controversial that didn't have documented, factual errors in it.
Right.
So here's the other issue. Then I write a book. So I spent 5 years writing a book on this subject. The book, at one point, I had a 400,000 word unfinished draft that my editor, bless his heart, read because I was wondering,
the horror.
Yeah, could we make it 2 books? Which he said we couldn't. So I cut it in half. I end up with about 180,000 words. It's 160 pages of endnotes and bibliography. Now, imagine, and I've said this to people, imagine a journalist came along and did more research than you could ever imagine and wrote a 500-page tome explaining that God exists. Okay? And you have friends who say that this guy did a pretty thoughtful job. Do you think you could read it and judge it fairly?
Well, if you're asking me, I would have a professional responsibility to read it at this point.
Right.
If it really was thought to be breaking new ground. But I mean, many people, I think this is a fairly well-known phenomenon, that people tend to silo themselves and not want to read something they are happy to not agree with, or they have a vested interest in not agreeing with.
It's not only not want to read, it's not be able to read. So I try to imagine reading such a book, and I can't actually imagine. And again, you have a professional obligation. My mother was a militant atheist. I was raised to be an atheist. I just what I am and how I think. And I can imagine after 20 or 25, every paragraph I'm going to be thinking, what about this? What about that? Why didn't you say this? Of course, that's not how you interpret it. I mean, you know, all these knee-jerk responses. And I'm simply not going to be able to do it. The cognitive dissonance is going to be so profound that right or wrong, I'm not going to be able to get through that book. And then there's this tendency to just assume it's crap. And one of the jobs that I always considered from the time my first book came out, the first book I did on this physics collaboration, which was called Nobel Dreams. So I'd gone off to Geneva to write what I thought was going to be a book about a great discovery, and I turned out to write an expose about the politics and sociology of high energy physics, in which I was in part taking down this Machiavellian Nobel laureate. And a couple of years after the book came out, a colleague of his, a physicist, met one of the chief researchers from this physics experiment in Geneva at a conference, and he asked him if he read my book. And this guy, who I actually liked a lot, said to him, "It's crap, I haven't read it."
Right.
And I always considered my job to get the medical research community past the "it's crap, I haven't read it" stage, because that's a completely natural response to all of us whose job isn't, job obligation doesn't require that we have to read these books.
Yeah.
And I have them myself. I once told a very good friend, I actually became friends with John Horgan, who you might know, when he wrote his book, The End of Science. And I saw him at a conference, and I told him the story about "it's crap, I haven't read it." And I said, "That's how I feel about your book."
Yeah. Well, I feel that it's crap, and I have read it.
Well, it's funny. I now, and I've told John this, I now have to read it because I'm involved in a project that I think I have to understand, because maybe I was wrong.
Right.
I'll take your but anyway, so that's the issue. You write a book like this, the general response in the field is "it's crap, I haven't read." And I knew that enough to know that I wasn't actually writing for nutritionists and obesity. I didn't think I could say anything that would change their minds any more than, and we can't imagine what would have to be in a book to make either one of us believe in God.
Well, but there are some important differences there. I mean, I think the analogy does break down, because what would have to be in that book is not at all likely to be in that book, given the way the universe is and given what we know about the origin of specific religious doctrines. Whereas when you're talking about nutrition, you are talking about science that is being done or been done and ignored, or is yet to be done, or experiments that can be proposed and run and will change the state of our knowledge in very short order. So it still is confounding, and a genuine mystery that we are as confused as we are about what to eat, and that your claims, however controversial, could be so difficult to quickly debunk or not, and that the acknowledgement of the falsifiability or unfalsifiability of any one claim couldn't come very quickly from those whose job it is to evaluate claims like that.
Right. Well, and that the problem is at no point does someone's job become evaluate. Well, at what point does someone's job become evaluate the claims of a journalist?
But I mean, for instance, there's got to be, for all the people who hated the Atkins phenomenon and thought that it was dangerous, if in fact it was dangerous, it should be pretty easy to prove that ramping up saturated fat intake, all things being equal, is bad for you.
Well, so this is what the reason Atkins dominated that New York Times Magazine story. That story was, the assignment was, let's figure out what started the obesity epidemic. Let's speculate, because the obesity epidemic was relatively new news. It was localized in time. As I was doing that study, the research, I came upon 5 studies that had been done, which is exactly what you are talking about. And they had been done but not yet published. They'd been discussed in conferences where researchers had randomized subjects, obese, overweight subjects, to either a Atkins diet, which you can eat as much as you want, high fat, restrict the carbohydrates, or an American Heart Association low fat diet, where you're calorie restricted. So one diet, you're eating double cheeseburgers, with bacon and eggs and bacon for breakfast and all these things that are supposed to kill you and as many calories as you would like. The other diet is the one we were all on for much of our lives, a piece of lettuce with an ice cream scoop of chicken salad, or a skinless chicken breast with sauteed broccoli, something like that, provided it's sauteed without fat. Anyway, in all these studies, and this was what drove me to the conclusion, the Atkins diet, not only did it lead to more weight loss, despite being calorie unrestricted, which suggests that calories don't really matter.
It also suggests that people are reaching satiety so much earlier on that diet that they're just eating less.
Yeah. Exactly, and that's the conventional thinking.
Right.
Or the other fact with these diets is, in each case, the folks on the Atkins diet, their heart disease risk factors improved more than the folks on the American Heart Association diet.
Right.
So that was, again, these trials have been done, and they all pretty much show the same thing. There's a very consistent finding that people who go on these diets are healthier. But rather than, so the medical community can respond by saying, oh, sorry, we were wrong. This is a healthy way to lose weight. Or they could respond by figuring out how they were right after all. And taking that. And so again, I've been arguing that they took the perfectly human second tact, and rather than ever acknowledging that they just made a mistake. But clearly these studies were the sort of anomalous observation in this field. If you believed that people got fat because they overate, they should lose more weight when you restrict their calories than when they don't. When you don't, and that hypothesis failed. And if you believe that high-fat diets cause heart disease, their heart disease risk factors should get worse when they eat high-fat diets and high-saturated fat diets and the greasy cheeseburgers and all that stuff. And that hypothesis also failed this particular test. So again, part of the reason, is I mentioned in passing, I co-founded a not-for-profit called the Nutrition Science Initiative. And we've run into some serious problems recently, but before we ran into those problems, we've had support from a very beneficent foundation so that we could fund about $20 to $30 million in 4 trials that begin, 4 experiments that begin to really try to resolve these controversies. So in one way to think about it is that, remember when I said you could eat 3,000 calories in which you fix the calories, but one group gets steak, green vegetables, the other gets steak, potatoes, sugary beverages, and green vegetables. They both get the same amount of calories. Does the macronutrient difference have a significant effect on fat accumulation? And by fixing the calories, you've removed hunger from the issue and everything else. And those experiments can indeed be done, but they're difficult to do. The more we learn about it, the more we learn how difficult they really are. And
but now you attempted, or you did one. I mean, this is the Kevin Hall study that I referenced. What happened there? I mean, because my understanding was that this was a metabolic ward study where you actually just put people essentially in a hospital, right? And you have complete control over their intake and their output.
Well, this was a pilot study. And so the idea was, again, it's a bit of the whole thing is embarrassing. I mean, there are various, but
that happens in life. I mean, just unpack that if it's at all
so
intellectually useful.
When we found and part of it is embarrassing is because a lot of my assumptions turned out to be incorrect, not necessarily the scientific ones. So the idea we had, so I co-founded the Nutrition Science Initiative, NUSI, with this researcher, physician, Peter Attia. And we got funding from the Lauren John Arnold Foundation. And the idea was we could go to very influential obesity researchers. And I had interviewed effectively everyone doing important work in the field. I mean, hundreds and hundreds of people between my articles and books. And so I had a feel for who was thoughtful, despite being dogmatic in their belief that obesity is an energy balance disorder. So we approached 3 of these researchers at Columbia University, at some Pennington Biomedical Research PBRC Center in Baton Rouge, Louisiana, which is a major obesity research, and then NIH, where this young biophysicist Kevin Hall was, and Kevin had made his name. And Kevin and I had spoken a lot. He had read my book. We'd had a lot of very interesting conversations. A couple of other researchers came along with the researchers we approached. And the idea was, and what we would say to them when we met is, look, you guys believe that a calorie is a calorie, and that the way that foods influence weight is effectively primarily through their caloric content. And we believe that the way foods influence weight is through their effect on sort of hormonal homeostasis. Fancy word, that if a food influences insulin, it's going to influence fat accumulation. This will be independent of calories. So there are 2 different hypotheses. These 2 different hypotheses, the role of a good scientific experiment is you have competing hypotheses that will make different predictions for the experimental scenario you create. So we are going to create a scenario where our 2 hypotheses make very different predictions. So in effect, the scenario was, we're going to take these subjects, obese or overweight subjects, and we're going to figure out how many calories it takes to maintain their weight on a standard American diet, which is, 50% carbs, 35% fat, 15% protein, maybe 18% of the total calories will come from sugar. And once we figure out how many calories it takes to maintain their weight, and again, this is precisely the experiment I talked to you, our thought experiment, then we're going to switch them to the equivalent of an Atkins diet or a ketogenic diet. We're going to keep the calories fixed, but we're going to lower the carbohydrate content so that we minimize insulin secretion. And if obesity is an energy balance disorder, then the only way the foods can influence weight is through the caloric content. We're fixing the calories, so even if one food makes them hungry or not, that's not going to make a damn bit of difference in this experiment, because they're going to have to eat what we give them. And they shouldn't lose or gain any weight whatsoever when we switch them to the ketogenic diet, because we're keeping calories fixed. Now, in this other hormonal regulatory paradigm or hypothesis, that says if you lower insulin, they're going to mobilize fat from their fat tissue, and they're going to oxidize that fat as fuel. And there's no law of nature that says they can't burn more calories than they expend, than they take in. So if we lower insulin enough, these people on the ketogenic diet will mobilize their fat from their fat tissue. That fat will be oxidized, and that'll manifest itself as an increase in energy expenditure. So they will expend more energy than they take in, and but they will do so because they are now burning their own fat stores, which they couldn't do on the standard American diet. Does that make sense? So you could say, you would say for somebody to lose weight, they have to be in what's called a negative energy balance. They have to expend more energy than they take in. What we're saying is, hey, you could change the regulation of the fat tissue such that they're, in effect, losing weight, and they're going to oxidize that fat, and you're going to see this negative energy balance. So that was the gist of it. We wanted to do a randomized controlled trial because without randomization, you can't infer causality. So there are a lot of ways that experiments can be misinterpreted. And one of them, particularly in a scenario like ours, is maybe if you spend 4 weeks on this run-in standard American diet and then shift to the ketogenic diet, maybe something happens after 4 weeks that would happen with any diet. So what you see, whether it confirms our hypothesis or not, after 4 weeks, without randomization, might be due to some time effect. After 4 weeks on a diet in a metabolic ward, your body does X. We didn't know that, but now we're going to say that X was caused by the diet. So the way you deal with it is you randomize, but in that way you would run the subjects in and randomize them to different diets, including a control diet in which they stayed on the same diet. So you could see what happens after 4 weeks if people don't change their diet at all. That's just basic science. And then you have to figure out how many subjects you need to make sure that you're likely to see an effect if one exists.
Right.
And in order to figure out how many, we had no way to figure out how many subjects we needed because nobody had ever done this experiment before. So we decided that we would do a pilot experiment. We would do a non-randomized trial that can't infer causality because it's not randomized, can't infer anything meaningful, but we might get a feel for the size of the effect such that we can do more, such that we know how to power the full-blown randomized controlled trial. So we would do a flawed study. A pilot study is by definition cannot infer a result. That would cost only about $4 million so that we could then spend $20 to $25 million on a study that's likely to be meaningful. And from there, a lot of things went wrong with the study. It turned out that, so the idea was the researchers were supposed to get the subjects in energy balance over those first months. So you know exactly how many calories you have to feed them to keep their body mass stable. But they couldn't keep their body mass stable. So they lost weight throughout that first month. And then, so right there, this is what I would say, if this was a rat experiment, once you realized that your rats were losing weight, you would euthanize the rats and start again. Because right there, the experiment has now failed.
Again, we've glimpsed another path to fame that you haven't taken.
So what happened is we did the study anyway. When the study was, you continue doing the study, you hope that you will learn something meaningful. And when the study was done, again, we had a lot of discussions. We have a very good scientific advisory board at the Nutrition Science Initiative, very influential, good scientists. And they read the papers and looked at the data and gave their critiques. And we gave them to the researchers, and the researchers could decide whether to use the critiques or not. And for reasons that still kind of mystify me, they decided to interpret this study as capable of inferring causality and saying that the effect they saw was not significant enough to believe that this hormonal regulatory hypothesis is right. And we would argue that, in fact, what they saw supports our hypothesis, but it can't be inferred anyway because the study wasn't randomized. And then it gets into this discussion of scientists versus these sort of weird nutrition science initiative people. And we had the funding, so we're biased. And I don't know, to me, it's just one of many studies that constitute maybe 90% or 95% of all science that can't be interpreted. And I'm perfectly happy to say we funded a study that couldn't be interpreted, and we wish it could have. We wish it hadn't failed, but it failed. They argue that I'm only saying that because I didn't like the results. And then I counter, but I did like the results, but you can't interpret them because it wasn't a randomized trial and they weren't in energy balance. And you don't know why they weren't in energy balance. And it goes back and forth. The idea, and the reason I'm embarrassed by all this is that our goal when we set up the Nutrition Science Initiative was to generate studies that were as unambiguous as science can be, where you don't have to take someone's word for what the result is. You could look at the data yourself and say, wow, that's clear, like cigarettes and lung cancer. Wow. I don't know how to explain that. I'm going to believe cigarettes cause lung cancer. In this case, we ended up with, there's a he said, she said. They say we're biased because we funded it. We say they're biased because they did, in effect, they overinterpreted the data, which is as good a definition of bad science as you can find.
Well, so then did the controversy over this break your foundation? I mean, it just seems to me that there's just more work to be done to do a study that everyone acknowledges is valid. I mean, again, this doesn't seem like
No,
the
absolutely. Yeah.
forefront of scientific difficulty to run a study of this sort.
Yeah, no, and well, it's again, it's surprisingly difficult. That was one of our learning experiences, was how easily a study like this can go off the rails. And again, the epilogue of Good Calories, Bad Calories, my first book was in part meditation on how the pseudoscience of nutrition and obesity research, but I was criticizing it on a macro level, and this was my learning experience and how easy it is for these experiments to fail on a micro level.
Hmm.
Again, if we were working with rats and this was a functional science, this would have been the first of 20 or 30 studies that would end up being done, where you do the study, it would be heavily criticized, people would point out all the things that were done wrong, you would redo the study fixing those things, and the criticisms would wash in, and you'd do it again and do it again, and eventually you would asymptotically approach some result that nobody could think of how to criticize. But because this is human research and it's expensive, the researchers decided to just make some definitive statement that I don't believe is logically defensible, that whether or not it would have been right if it was logically defensible. Yes, this was part of what led to my not-for-profits issues. Not all of it, and by no means all of it. We had other issues that, we were we're struggling, and we're struggling for good reason. The all of our fund, the bulk of our funding came from one organization, the Arnold Foundation. So when they lost faith in our ability to manage these experiments, which happened largely because of the mess that with this energy balance consortium, they lost faith in us managing other experiments. We argued, look, we have other experiments, 3 of them that are out there that have run beautifully, in which our relationship with the researchers is beautiful, but I can't blame them for losing faith in us. So, and they were our major source of funding. So, when you're completely dependent on one foundation, it's a very dangerous place for a not-for-profit to be. And because we were in effect founded in collaboration with them, we were completely dependent. You're absolutely right that this can be resolved. I mean, it's clearly can be resolved by good experiments. The problem is somebody has to pay for those experiments. So the Arnold Foundation had a request for proposals that were based in large part on my work and thinking, and they had a lot of proposals that came into them from the research community, and they're contemplating funding them without our involvement. And occasionally they ask for our input on whether or not we think a study is well designed and can answer the questions, which is, the study design determines what question is asked. And if you don't understand this issue with energy balance, is it a hormonal issue or an energy balance issue, you're not going to ask the right questions. So, and then the NIH I haven't gotten anyone significant in the NIH past the "it's crap, I haven't read it" level about my work.
Well, it seems to me the energy balance controversy, while interesting and I would agree relevant for understanding all of this, but whatever side of the energy balance story you come down on, or reality comes down on, it still could be true that eating a low-carb diet leads to weight loss and less cardiovascular problems for a host of reasons that we haven't yet characterized. So whether it ramps up metabolism or just reduces hunger and food cravings, or it does both, or there's some other mechanism that we don't understand, it should be easy to establish the health results of changing your diet in this way. And you write as though those data are fairly well in hand. I mean, how confident are you that reducing carbohydrate intake in your diet proves to be a good thing for weight loss and for the markers of cardiovascular health?
Okay, so the existing experiments will tell you that if you shift from that this low carbohydrate, high fat diet is a healthy diet over the course of the length of the experiments, a year or two. So in that, I'm confident. I'm a big believer in experiments. I think you need experiments to understand the observations, and the experiments continue to support this way of eating. So now the problem is, and this gets back to observational epidemiology, the part of the third pillar, the mostly plant pillar, and this is all interwoven. If you were to do what, for instance, the Harvard School of Public Health has been doing since the late 1970s, create huge cohorts of tens of thousands of men and women. So the famous example is the Nurses' Health Study at Harvard, and ask them what they eat in 1980, say, with a food frequency survey, and even let's assume you could get a precise answer about what they eat, and then follow them for 20 or 30 years and find out what the diet, what diseases associate with what components of the diet. What you'll find is that people who eat mostly plant diets are healthier than people who eat mostly animal product diets. And then the question, so again, because this is what the Harvard School of Public Health does, they then assume that those associations are causal. And they will say that if we all eat mostly plant diets, absent white bread and sugar, we will be healthier than if we eat mostly animal product diets, leaving the environment and ethical issues out of it.
Right.
And so that data, the observational data, says the mostly plant diets are healthier, and the kind of diet that I eat and the kind of diet that I believe many obese and diabetic individuals, or most of them, should eat if they want to be ideally healthy is ultimately a mostly animal product diet. It's hard to do a low carb, high fat diet without a lot of animal products, because animal products are in effect carb free, not including dairy. So you've got.
Let me just plant a flag on something you said. You said taking out white bread and sugar. So, there are a few points here where there probably is no controversy, right? Is there anyone saying that reducing your sugar intake, sucrose, isn't necessarily a good thing? Everyone is for that, right?
Again, everyone outside the sugar industry.
Right.
But again, the idea is the reason sugar is bad is because it's empty calories. It's excess calories. It represents a lot of the calories we eat. So when I'm making my arguments, like I said, all of this science is interwoven. The reason I'm so focused on this energy balance conception of obesity is because you could dig into, for instance, the USDA dietary guidelines, and you'll find out that the dietary guidelines are determined by, for instance, setting a caloric level for what would be a healthy amount of calories, and then you fit in, okay, we need so much protein, we need so much green vegetables, we need so much of this, so much of that, and everything is sort of calorie based.
Right.
And so as long as you're thinking in terms of calories and this obesity being caused by caloric overload, you'll never act. There's a lot of things you can, people will get healthier, and they are getting healthier, at least in the short term, by shifting to these lower carbohydrate or very low carbohydrate, higher fat or high fat diets. But we don't know. I've eaten this way for 15 years. I'm still waiting to have a heart attack.
One issue I have here, just personally, is that, I've been trying to be a vegetarian for now coming up on 2 years, and eating what I consider medicinal fish from time to time, because after my first 12 months as a vegetarian, I was feeling like I was missing something, and I don't actually like fish all that much. What I actually would want to eat is a steak or a hamburger, but I stopped all that for ethical reasons, and I will table for the moment how we can distinguish the ethics of killing fish from killing cows. But in any case, I would be much happier being a pure vegetarian, but if I accepted your reasoning here, and maybe even being a vegan, although that's not something I've actually attempted, and would be more worried about my health in that regard. And now I can get hate mail from Rich Roll and his fans. If you don't know him, he's a famous ultra athlete vegan who's in fantastic shape and health, it would seem. and a very nice guy. I met him briefly. It becomes problematic to think about following a very low carbohydrate, high fat, high protein diet as a vegetarian if you're committed to the ethics of doing that. Is it just not doable, or do you actually see a vegetarian path toward your version of optimal health?
Well, there are variations again towards the arguments that are being made. So I think one of the ways in my dark moments when I have to give myself credit, back in 2002 when I wrote the New York Times Magazine article, "What if it's all been a big fat lie?" I was making the argument that the fundamental problem with modern diets is with probably the refined grain and sugar content, not the fat content. And then Atkins was the extreme example, and then the thing that ratcheted up the controversy. Back then, even saying that was controversial, that we should be looking at the carbohydrate content of the diet and the fat content's probably irrelevant. Now that's well accepted. So that's gotten to
Right.
this level where everyone agrees, and some people give me credit for that. Most people just say it would have happened anyway, and so you can improve as a vegetarian, clearly, and I would argue, so it used to be if you were just looking at low-fat diets and you were put on a low-fat diet, the American Heart Association was as guilty as this as anyone. I mean, I have an American Heart Association dessert cookbook around here with luscious, desserts that they consider healthy because they're low in fat, even though they're still loaded with sugar.
Hmm.
So the idea is you can, even as a vegetarian, if you get rid of the sugar in your diet and eat what Tim Ferriss would call slow carbohydrates, unrefined carbs, quinoa instead of white flour, that kind of thing. Low, what are technically called low glycemic index carbohydrates, you'll be a lot healthier than if you can eat a vegetarian diet with sugar and white bread.
Right.
And it's going to be, I think you'll be in a lot of trouble. So the first thing you do is get rid of the sugar and the refined flour, highly refined flour, and you eat healthier carbs.
Right. And again, basically, as far as I can tell, no one doubts the wisdom of that advice. If you tell your doctor or your nutritionist or your personal trainer or anyone who's paying attention to anything in this space that you have decided to reduce sugar and refined flour intake and change nothing else about your diet, there's just unanimity on that being a good idea.
Yeah, absolutely. But keep in mind, just because I don't want to let the health community off the hook, from the 1970s through the early 2000s, there was the worst, the only public health recommendations we got along those lines were this idea that, like the U.S. dietary guidelines would say, avoid too much sugar. There's this kind of general idea. I mean, intelligent, higher socioeconomic status people knew that they shouldn't, even Wonder Bread was questionable. But the public health advice was low fat, low fat, low fat, to the point that the Centers for Disease Control was telling the food industry, please give us low fat products, and you get products like low fat, high sugared yogurts, or health bars. Think of these health food bars that are, you have no issue giving your kids, even though they're basically what they are low fat candy bars.
Right.
So our public health efforts were aimed at lowering the fat content of the diet, lowering the saturated fat content, and paid no attention to what we now accept as, conventional wisdom. Yeah, don't eat sugar and white flour. Excellent. Everyone agrees. Even the government agrees. But nobody, I just wanted to establish, because I'm that kind of person, that a huge mistake was made.
Yeah.
And
Yeah.
the public health, and we have to keep that in mind so we don't make further mistakes down the road. We have to understand that mistake because it was tragic on many levels. Now, the next step, I mean, there are people who would argue it's exceedingly difficult to have a nutritional, to get to necessary vitamins and minerals you need in a vegetarian diet. It's a lot easier with animal products. Yesterday, I had coffee here in Berkeley with an agricultural economist who was saying, that if you want to, it's well known in the health sector that if you want to improve the diets of poor populations and impoverished populations, you want to get them to have more access to more livestock. Bill Gates has a has a column on his blog about the importance. If he could do anything in the world, if he was suddenly not a billionaire anymore, he would raise chickens.
Hmm.
So he could get the impoverished people of the world to eat eggs.
Right. Right.
And it's
Although as a vegetarian, that's okay. So eggs, you can
yeah.
add eggs and dairy. If your kids told you that after all your research, your 3 books, your decade of hectoring them about their diet, no doubt, they were going to be vegetarians who ate eggs and dairy, and they believe that a diet with unrefined, just loaded with unrefined carbs and fats too, and whatever protein they could get from eggs and dairy was the healthiest, and they were just going to cut out refined grains and sugar. How concerned would you be for their future health?
Well, first of all, I have to say, because we live actually in Oakland, right on the border of Berkeley, it's just a matter of time before they say that. Okay. And I've been waiting for it. For their health, not that much. I mean, will they, I think that's basically a healthy diet. Much of the world survived on diets like that and did not have obesity and diabetes until they started eating the foods that my kids are not going to be eating, should they eat that way. Now, first of all, they better cook for themselves, because I'm not very good at that kind of food. But other than that, we don't have an issue, and I think that's a healthy diet. Now the problem is if they start getting obese and diabetic, which could happen. I doubt I'd see diabetes in them if they keep sugar and flour. I think that would help prevent that, unless it ran in our family, which it doesn't. There's no apparent family history, but they might start getting fatter on those diets. And if they had a predisposition to get fat, I would worry about that, and I would probably tell them that's going to make it harder if you want to remain lean. And I think remaining lean is a sign that they're healthier if they're leaner. Not necessarily the case.
So what's the remaining offender in that diet if you're cutting out white flour and sugar, but you're leaving in whole
Some
grain
people
products?
still can't tolerate, I would argue, so I'm arguing again that obesity is a hormonal regulatory disorder, and it's triggered by the carbohydrate content of the diet. So specifically by the sugar, and I think sugar is both necessary and sufficient, and sugar and white flour, highly refined carbs. But one of the arguments I make in my book is this is also a problem that will be passed down from generation to generation. So the initial genetic susceptibility is to the carbohydrate content of the diet, but then it's going to be exacerbated when mothers are pregnant. If the mothers are getting heavy, if they're obese or diabetic, or they gain a lot of weight in pregnancy, or they're what's called gestationally diabetic, they are going to give birth to kids who are more predisposed to get fat, and so less carbohydrate tolerant. And by today, with the world, again, I think the world is full of people who are obese and diabetic who do not eat sugar and white flour because they think it's unhealthy. But if they were to, and they may be vegetarians, they may eat pretty much exactly as you do, and yet remain obese and diabetic, and could reverse much of the obesity and much of the diabetes by getting rid of all the carbs in the diet. And again, but now you've got the animal product problem.
Yeah.
So, but if you think it's all about calories, we don't have any of these discussions.
Right.
And none of this ever gets tested. None of it gets worked out. It's only if you can get over this energy balance idea that you start having discussions that can help people and lead to science that might clarify this, if I'm right.
Where does alcohol consumption fit into this picture of carbs and insulin regulation?
Well, funny, I got an email from someone after the case against sugar came out saying, what about the maltose in beer? And I said, well, I could write a book called The Case Against Beer, but I don't think anybody would read it, and certainly beer drinkers wouldn't care.
Didn't somebody write a book, The Case Against Football? That wasn't the title, but there was a journalist who watched enough football and read the head injury data and thought football should be illegal.
Yeah. I mean, already I've got a latex Halloween Grinch mask. I'm always tempted to take it to lectures and just put it on when I give my lecture. Yeah, alcohol, I mean, clearly, again, the science is confounded. Clearly, beer is fattening. Nobody has ever, the concept of a beer belly tells you it is. It's probably could be the effect of the maltose, which is you can think of as a refined carb. It could be the alcohol, which is metabolized in the liver. So one of we not only do we have epidemics of obesity and diabetes, but we have epidemics of something called non-alcoholic fatty liver disease. I mean, it's an epidemic proportions in America now. And by that, I mean, 30 or 40 years ago, maybe even 20 years ago, if you were diagnosed with fatty liver disease and told your doctor that you didn't drink alcohol, your doctor would assume that you were lying. And then fatty liver disease started being diagnosed in children who clearly don't drink alcohol. And now it's called non-alcoholic fatty liver disease. And I forget the numbers, but they're enormous. Tens of millions of Americans supposedly have this, and millions of children. And it's not benign. And the question is, what's causing it? And to me, the obvious culprit, so this is where sugar comes in, because sugar is a compound it's a simple carbohydrate that's made up of two simpler carbs, glucose and fructose. So when we consume starch, the carbohydrates and starches and grains break down to glucose in our gut, and they transport it into our bloodstream, and blood sugar is technically blood glucose. So as the glucose level in your blood goes up, that's your blood sugar going up, and virtually every cell in your body will metabolize glucose. The fructose is the sweetest of the carbohydrates. It's what makes sugar sweet. It's what makes fruit sweet. And the fructose is metabolized in the liver. And we've known this for decades, if not a century. And when your liver has to metabolize fructose in large quantities, it turns it into fat, triglycerides. And now we have an epidemic of non-alcoholic fatty liver disease, fat accumulation in liver cells in a world that consumes an awful lot of sugary beverages. And so the idea is basically that sugar is doing the same thing that alcohol is doing. The alcohol is also metabolized in the liver.
Right.
So if we're getting back to the question, like, I think anyone who consumes what we'll just call excessive amounts of alcohol knows that they're taking a risk with their health. Nobody who drinks 8 shots of whiskey in an evening is thinking this is good for me. I don't know, maybe a few people are, but for the most part, we accept that you're risking, that there are health risks associated with this. What exactly they are.
Except those risks, insofar as I'm in touch with the data, it's been some years since I read the papers on this, but last I looked, you could basically consume an entire bottle of wine and have that be better than teetotaling in terms of its influence on mortality.
Yeah, there's an association between moderate alcohol consumption, and by that, people usually mean moderate wine consumption, and longevity. And that's led to this idea. Also, it's supposedly an explanation for the French paradox, which is a population that eats high-fat diets and doesn't get a lot of heart disease. It's only, of course, a paradox if saturated fat is the cause of heart disease. It's not a paradox if it isn't. So there's a lot of that associational data. In fact, one of the findings that came up repeatedly when I first started my research back in the late 90s, and I was looking at a lot of these cohort studies, they're called, and there weren't an infinite number, as there probably are today, a common association, and all of them was moderate alcohol drinking with longevity and lower morbidity, lower disease rates. And then the question is that causal? So if you're a teetotaler and I take a population and I tell 10,000 people and 5,000, I say you can't have an alcoholic drink for 10 years, and you 5,000, I want you to drink 4 glasses of red wine every night, who's going to be healthier? And I'm actually going to vote for the teetotalers in that scenario. I don't know if the wine drinkers are going to be unhealthy because of the wine or because of the calories in the wine or because of the tannins in the wine. Who the hell knows? I'm just going to vote for the teetotalers because that's what my intuition tells me. The problem is when you do those association studies, I think there's a fundamental difference in our population between teetotalers and people who drink 3 or 4 glasses of wine a night and binge drinkers. And I think when you're picking out the people who drink, I'd say 2 or 3 glasses, I start getting nervous by 4.
Right.
You're picking out people who have a certain attitude towards life.
Which comes with many other variables, yeah.
Which comes with many other variables and may indicate a certain inherent healthfulness. There's something called the healthful user effect that I discussed in my New York Times Magazine art cover story on epidemiology, which is a fascinating study. It was actually back in the 70s, and people were testing a cholesterol-lowering drug that they thought might reduce rates of heart disease, and they found out that it didn't. And after they were done, they said, well, wait a minute. When we look at people who we randomized to take this drug, a lot of them didn't take it. So let's just look at the people who took the drug and see if they had a reduced effect. And lo and behold, they had like 40% less heart disease, 50% less. So now you're tempted to say the drug reduces rates of heart disease, but they were smart enough to say, wait a minute, a lot of people didn't take the placebo either. So let's look at the rate of heart disease in the people who took the placebo versus the people who didn't. And it turned out that the people who took the placebo also had 50% less heart disease.
Right.
Which led them to conclude that there was something about people who followed their doctor's orders that made them healthier. And you don't know what it is. They could be inherently, it could be that people who are unhealthy feel bad about themselves. They just can't perform as well. And so they don't tend to follow doctor's orders and take their pills. You have no idea why. And that's
also following doctor's orders can correlate with many other healthful practices that people are just doing effortlessly.
Smoking less, exercising more, eating, sleeping better.
Yeah.
And you have no idea what it is. It could be an inherent quality of the individual, and it could be a reverse causality where healthier people tend to follow doctor's advice. And it could be that following doctor's advice associates with all this other healthy behavior. You don't know.
Well, listen, Gary, we're coming up on 2 hours here, and I want to bring this to a couple of actionable points for people. I also want to encourage you to keep doing and or inspiring this research, because I feel like whatever controversies have occurred recently aside, or even because of them, you are well positioned to assemble a team of rivals who can propose studies that they would find convincing, even if they're disposed to disagree with your conception of the metabolic pathways here. And just in the spirit of Popperian science, you can falsify these various hypotheses in a decisive way. I mean, you could crowdfund this. You could put together a compelling story which would allow, even some of the people you've attempted to collaborate with first, Kevin Hall, who ran this pilot study. It seems like you could propose in advance what it will mean to cross into the end zone and acknowledge just exactly where the 1 yard line is, and just keep advancing the ball.
Well, that's what I think. Well, clearly, that's what I think has to be done. I would love to figure out how to step away from this and be happy with my life, but I don't think I'm going to figure that one out, considering the constraints of my character. My argument, if I could, because Francis Collins is the director of the National Institute to Health, if I could call him up, get him on the phone. I used to be able to do this briefly. I don't think he'd take my call at this point, but
unfortunately, I can't put in a good word for you with Collins, because I wrote a New York Times op-ed saying that it was an intellectual scandal that he had been appointed to head the NIH. So
yeah, that would probably put us.
He's not too fond of me.
Yeah, this is the argument I keep making over and over again. I don't know if you noticed recently, I had Jerome Grobman of the New Yorker recently reviewed my book in the New Yorker
Hmm.
and condescendingly dismissed it, and very condescendingly dismissed it.
And he's an MD, right?
And he's a professor of medicine at Harvard
Yeah.
and has clearly not been a fan of my work since 2007 when I wrote this other New York Times Magazine cover article that was used the work of some of his Harvard colleagues as a case study in bad science. And the point I made, he reviewed the book without ever discussing the fact that there's a diabetes epidemic and an obesity epidemic, and that this isn't just about you and I deciding what diet we should eat to be healthier, but that in order to to reverse an epidemic, you have to unambiguously understand its cause. And that if we had any other scenario by where diabetes prevalence in this country has increased 700% since 1960, if you believe the CDC data, and that's a tragedy. And again, you have this epidemic worldwide. Back in October, the Margaret Chan, Director General of the World Health Organization, gave a keynote address to the National Academy of Medicine where she described the obesity and diabetes epidemics as slow motion disasters and actually predicted with virtual certainty that they would get worse.
We're talking about type 2 diabetes, right? Or has
Type
there
2
been an
diabetes,
increase in type
yeah.
1 as well?
Type 1 has increased, but the huge proportion, and we would want to understand why. But type 2 has increased. That's the 95% of diabetics are type 2. And the epidemics are type 2. And so the argument I'm making is you've got these tragic epidemics that are out of control. You have the Director General of the World Health Organization predicting that they're going to get worse, that they're not going to be able to curb them in. And we have a medical research community and public health authorities who are convinced that they know what's causing these epidemics. This is the overeating thing. People
Right.
are eating too much, they're under-exercising, they're sedentary. And in any other scenario like that, we would be questioning our assumptions. Imagine if, whatever, 1985, the HIV virus is identified as the cause of AIDS, and 30 years later, HIV/AIDS prevalence and mortality had increased 700%. We would be overwhelmed with scientific investigations and public health investigations trying to figure out what it is we don't understand about this disease, what mistake we had made in assuming that it was just HIV. And in obesity and diabetes, there's none of that. The assumption is ubiquitous as we understand the cause of the diseases. We don't have to challenge our assumptions. And there is clearly, effectively the only journalist who's done the job of going back to see whether these assumptions are valid. And I think I make a pretty compelling argument that they're not. And you can see them. It's not just what mistakes were made. You can actually see in the literature who made them and when they were made and how they were made. And you could then, I wouldn't take my advice for it anyway, but all of this can indeed be tested.
Yeah.
And that's what we have to do. So again, part of my job has always been convince the community this isn't just about, like I said, how you and I should eat so that we weigh 10 pounds more, 10 pounds less, or we live to be 85 or 87. It's about establishing what is causing these epidemics because they're out of control, costing the medical system in the US. The CDC estimate is $1 billion a day.
Yeah, it's a remarkable health crisis that, because it is on its surface linked to the just most common human behavior, it gets moralized in a way that very few things can in the
Right.
disease space. So people are blamed for being obese, and any understanding of the biology here that seems to exonerate them as agents,
Right.
there's a very moralistic rejection of that interpretation of things, because I mean it comes back. I mean, religion, or at the very least its shadow, can be seen here, because there's this basic notion of sin that every religious person is operating with, and if you can pray the gay away, certainly you can pray the donuts away.
Well, that's the thing. One way or the other, it becomes you take a physiological defect and you turn it into a moral failing.
Yeah.
And it's incredible. I can't tell you how ubiquitous this thinking is, even by people who don't realize they're thinking that way.
Yeah, you're judgmental of an obese person in a way that you couldn't be judgmental of a person with a brain tumor. And it's because it is obvious that they keep eating, right? And so they are part of the process that is causing them to gain weight.
Yeah. And as long as you're thinking it's an energy balance thing, one way or the other, they're taking in more calories than they need. And that's a behavior. It's not a physiological problem. That's a behavior.
Yeah.
Might be triggered by, who knows, the leptin resistance. You could think of all kinds of ways to explain why their brains are making them take in excess calories. But it's ultimately the explanation. Then what we do today, then we blame the food industry. So, the food industry makes it too easy for them to eat, this whole idea of bliss points. And, they make it so that we can't say no to the Doritos, and that we can blame the food industry. We can blame the obese people. We don't have to blame ourselves for simply misunderstanding on a very profound level the cause of these disorders.
Given the current state of uncertainty, but your confidence in the midst of it on this thesis, I mean, how do you, as a parent, live? And this will be my final question. So you have kids. I know you've been asked this question before, but no matter how convinced you are of the validity of this thesis and your duty as a parent to keep your kids healthy, how do you regulate or struggle to regulate their sugar intake? Just how Grinch-like are you in not punctuating their lives with celebratory sugar intake?
When it's within my power, their sugar intake is very low. Okay, so we don't keep sodas and fruit juices in the house. They know that when dad is cooking, they're not getting dessert. They know enough not to ask me for cookies, but we have cabinets full of health food bars and air quotes. And when it's out of my control, when they're at school or they're at parties or they're at athletic events, then it's out of my control. I don't try to prevent it. I'm guilty. I'm a hypocrite in that I am guilty of rewarding them on occasions with sweets because I think they will be healthy. Again, we don't have a family history of obesity and diabetes and heart disease. If I can keep it to the kind of diet that my health conscious mother fed me on in the 60s, I think they'll be relatively healthy. And, when they're 18, they're on their own.
Right.
I think it's our job as parents to educate kids in what's healthy eating, just as it is to educate them on the ethical behaviors and morality. And they don't have to listen to me and their kids, and they'll become adolescents, and they'll probably actively dismiss what I say, but hopefully when they get older, they'll come back to it.
Well, they'll become Bible-thumping donut chain operators if they
Quite
really rebel.
possible.
Yeah.
If it makes them happy.
Well, listen, Gary, it's been great to talk to you. And just a final piece of information: where can people send you the hate mail they haven't been able to get to you on social media? What's your Twitter handle?
Well, Twitter handle is Gary Taubes, and it's easy to find. And my website is garytaubes.com. And I try to answer most emails, although it's getting harder and harder. That's another lengthy conversation. But garytaubes.com, and Twitter is Gary Taubes, and Googling and the books, I hope, are easily available. So.
Yeah, no doubt. I'll provide links to all of that on my blog where I embed this podcast. And yeah, again, I encourage you to keep inspiring, if not directly funding research, because these questions are answerable, and it would be great to have more clarity, whatever the answer is, and to see you on, part of that panel discussion.
Well, we used to talk about at my not-for-profit, what would constitute success? And to me, success is, so I can get exercised about obesity in children, because if I'm right, um, obese children who are pushed to eat less and exercise more are being tortured, in effect. So being an obese child is anything but fun, and then having your obesity treated by something that would torture anyone else is unacceptable. And so my feeling is, again, assuming I'm right, I think there's a lot of evidence to assume I should be, but everyone should get the right advice in this nation. Everyone you go to should reinforce the advice of how people need to eat to be, at least metabolically healthy, if not as lean as they can comfortably be. And that's, pediatricians and you talk about keeping your kids away from sweets, and it's sort of how many juice boxes, or my kids go to sporting events, you give them popsicles and juice boxes when they're done. Preschools, that juice boxes and sweets are acceptable snacks, and again, they're a source of joy. I understand that. There's no way in this society, there's no way to avoid that this is a way to make children happy and to distract them from their pains and uncomfortableness. But it would help if people, again, if I'm right, that this message was universally transmitted to the kids and to their parents.
I've been cutting down my sugar intake in anticipation of this conversation, and my wrath has extended to the rest of the family. So I'll report back after some months, and we'll see if the Harrises are lean and happy or just haggard and unhappy.
Yeah, leaner. That's what we look for. Leaner and happier.
Yeah.
Okay.
Listen, Gary, it's been a pleasure.
Thank you, Sam. It has.
If you find these conversations valuable, there are many ways you can support this podcast. You can leave reviews on iTunes or anywhere else the show appears. You can tell your friends about it, or link to it on social media. Or you can sponsor the podcast directly through my website. My support page has links to Patreon, where you can support the show on a per-episode basis. It also has Amazon affiliates links that you can bookmark, and then you'll be supporting the show whenever you shop at Amazon, at no extra cost to you. All the resources you need to